Alright, this video is to help you write equations in the three different forms that we've been working on. First tip is just right at the beginning here. I'd put all three forms that we know up at the top of the sheet here. This isn't a question to answer. This is just for your own reference. That first one, slope-intercept form, y equals mx plus b. Second one, point-slope form, y minus y sub 1 equals m times in parentheses x minus x sub 1. And then the last one, standard form, ax plus by equals c. In this video, skip ahead as much as you need to get to the problems that you want to look at, but I'm going to go through maybe like one or two of each one of these just to give you a little bit of help on how to do the three different forms as a reminder. Let me start with number one here. So the first problems, as you can see, it says write an equation in slope-intercept form. So these first ones, we're using form number one right here, slope-intercept form. So remember that if I make an equation in slope-intercept form, the two things I need are right in the name, the slope and the y-intercept, correct? Well, in this first one, they've given me the slope already. And then they've given me an ordered pair, which is an x and a y coordinates. Remember, what we actually do is we take this equation, this form of equation up here, and we just plug in the variables that I know right now. So I know m, and I know an x and a y, and so I'm going to plug those in. And by doing so, I'm going to be able to find out b and make the equation. So let me start off by doing that. I'll try to make some room right here. This will be my y coordinate, -3 equals -4 my slope times the x coordinate, which is 4, plus b. Remember, this is me doing the algebra method. If you like this method, then this looks pretty familiar to you, or even if you want to start trying it now, that's fine. I'm going to keep working through it here, as you can see. If you like the graphing method instead, maybe I'll do one with the graphing method next, okay? But so there I get to this point. I got to add 16 to both sides. And so I get 13 over here, so b equals 13, it looks like. So now I found my b, which is 13. I had the slope, which was -4. Once I've found these two things, slope and y-intercept, I've got everything I need to make the final equation. Y equals -4x plus 13. And there is my final answer. Done with the first one. Now, I will do the next one just as a graphing one, just so again as a reminder, if you like the graphing method or you maybe want to start trying it for now for problems, you definitely can. I'm going to do problem number 2 here, but I'm going to go over to the graphing page that I've got set up already. The point that I've got 2 points here, 8, -8, and 0, -6. Again, the graphing method is great, but it doesn't always work in every single problem if the numbers get bigger or certain word problems. But I do like the graphing method, especially on ones when you have reasonable numbers. Okay, so now I'm over on a graphing slide. And on this slide, I'm going to plot those 2 points that we had. If you remember, they were 8, -8. I think it was 0, -6 as well. Good, so let's plot those 2 points, 8, -8. So 8, -8, I believe 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8, -8 I've got is right here for me. And 0, -6, 1, 2, 3, 4, 5, -6. So 0, -6 right there. So there's my 2 points. Now, remember, we're still making an equation in slope-intercept form. So m equals and b equals. I'm trying to find these two things, okay? Again, let's start by finding the slope and then the y-intercept. I think we'll see something with this particular problem that we can do. First of all, I've got to make a line here. And so let's see. Well, if I'm using you can imagine me using my ruler. But I'll try to make it as best I can. Something like that. There's my line. You should always use a ruler, make it straighter than that. But from there, I can find my slope. Remember, I always recommend going left to right, and then you do up or down first, like we talk about rise over run, correct? So it looks like I'm going down 2 right here, and then write 1, 2, 3, 4, 5, 6, 7, 8. So write 8. Okay. Well, those two numbers give me my slope. So m equals, it's like a fraction, negative 2 over 8, which actually reduces to negative 1/4. Yep, you should always reduce it when you can. So I've got my slope now, which is negative 1/4. Okay. Now, good thing about this particular problem is then usually I could use my slope to find more points. Up 1, left 4 from using my negative slope. Up 1, left 4. Up 1, left 4. I can make a bunch of points if I want, but I've already got my y-intercept in this particular problem because here's where the line crosses the y-axis. Happens to be one of my points. So in this case, it was 0, -6, or again, just -6, just like we had in the original problem. Every once in a while, they give it to you in the problem. Okay, not always, but if they do, great. And if not, then you just use the slope to backtrack like we did there and just land on wherever the y-intercept is. Where does your line cross the y-axis? Good, so I've got what I need for my equation now. Negative 1/4 x minus 6 is my equation for this problem. Okay, next problem we'll be doing is I'm going to jump down to one in the section for point slope form, which we worked on recently. Just remember point slope form. Again, right in the name is telling you there's the form up above as well. Y minus y1 equals m times x minus x1. Just remember, all you need for this form is a point and the slope of the line. So take a look at what I've got here. I've got 2 ordered pairs, or 2 points right now, so I can use either one of those when the time comes. But the other thing that I need to find out is the slope of the line, right? So I'm going to have to either graph these 2 points and find the rise over the run, or put them in a table. Again, we've done a lot of graphing, so I trust that you can do the graphing part. We've also done a lot of tables, but I'm going to stick with that for now. Maybe I'll graph something else later. But let me do the table way for now. So here's how I find the slope. I'm just going to use a table. Essentially, I'm just like subtracting or find the differences between these 2 ordered pairs. I've wrote them again. Realize I've written them just like they are, right? This is 9, 4, and then down here is 10, -2. So I think every once in a while people get confused by that, but just make sure you write the points just how they look. Otherwise, you will not get the right answer. I guarantee it. So put them in just how they are. Okay, good. Now what I'm going to do is use those to find the differences. So again, this is like on a number line. I'm going from 4 to -2 on the real number line. So that means I'm going down 6 spaces, right, or towards the -6 spots, so back 6. Then I'm going, in this case, from 9 to 10. Well, that's just up 1. So these 2 numbers make up my slope. And remember, it's rise over run, so I make a fraction if need be. It's -6 over 1. But that really reduces to just -6. So my slope for this line is -6. Then I can use either point. Again, it doesn't matter which one you pick. Let's say that you pick this one. So let's say you picked 9, 4. Okay? Then your equation would look like, remember this formula wants to be subtraction. So actually it's y minus 4 equals -6 parentheses x minus 9. So let's say you wrote it that way, okay, which would be great. You'd be correct. But now let's say your friend, instead, they're doing the same problem, and they use, whether they're entering it in or whether they are just completing the problem with you, they decide to use the point 10, -2. So they choose, oh, I'm going to use this point instead. Doesn't matter. Y, now remember the formula wants to be subtraction, so this would be y minus -2, which would be a chop situation, right? So really when I'm done, I'm just going to clean it up. But I'm just going to write +2 is what happens in these cases, right? Y plus 2 equals -6 x minus 10. Both of you have a correct answer. Those are equivalent equations in the end. So they both work just fine. I would accept either one as the correct answer for this problem. Okay, now I'm going to do a couple problems in standard form. I think I'll do 2 of these because I know if there's a form that seems to give people the most trouble, it's these standard form ones. But just remember, the crazy thing about standard form, first of all, is unless it's a word problem, this is the form. But A, B, and C, they don't mean the slope or y-intercept or anything. You can't plug those things in. So what we typically do for these ones in standard form is we start with slope-intercept form to get us going, and then we change it into standard form. So going down to this first problem here in standard form, remember, yes, they want you to make the equation as the directions say in standard form. But unless it's a word problem, there's not really a nice way to do that. So we're going to start with slope-intercept, as goofy as that sounds, but you're going to see why it's going to help us out in some of these problems. So I'm going to start off with slope-intercept, so I need the slope and the y-intercept. Hey, this first one, look at that. They give you those two things. So I've got m and I've got b. I can just jump right into making the equation y equals negative 2x plus 14. Again, I know this is slope-intercept form. We are going to change it now to standard form. Remember, the big defining feature of standard form is just the fact that x and y, right, x and y, those are on the same side when I'm looking at these. So I just now have to get x and y on the same side for this equation that I've started down here that's in slope-intercept form. So how am I going to do that? If it helps, draw your line here as a reminder, and I've got to get this 2x to the other side. It's negative, so I'm going to add 2x to both sides. And I'm going to get my final answer, which is 2x plus y equals 14. I don't see any fractions in that problem. That is my final answer. 2x plus y equals 14. Okay, I'm going to do one more of these just because I think that will be helpful. I'm looking at the problems. I think I'm going to jump to this last one here. This negative 4, 11, negative 8, 3. They give me 2 points to work with. And I'm going to do, again, I'm going to stick right now with the algebra method and using a table. And I'll try to do a graphing one on the back side here in just a little bit. But again, those, a lot of times we find slope and y-intercept with those. We do the same thing here, but I'm going to use the algebra. So to get myself started, let's make a table for these points, because that's going to get me, again, I'm trying to make standard form. Yes, I know. Don't think that I'm confused on it or anything, but as I've been telling you, standard form really to start. If it's not a word problem, it's not actually that easy to make. The easiest way we know how to make it is by making slope-intercept form. So we got to find the slope and the y-intercept. So let me put my numbers in up here. Negative 4, 11. Negative 8, 3. I'm going to find the differences now between those numbers as I take a look. Well, 11 going down to 3, that'd be like going down 8, right? And then negative 4 to negative 8, I'm getting more into the negatives as well, so that's going down 4. So what I've got here is negative, for slope, I've got negative 8 over negative 4, rise over run, which reduces down to just positive 2. Remember these two negatives here, right? Two negatives cancel out. They're going to make a positive. So it's just going to be positive 2 for my slope, which is kind of nice. Good. Okay, I've got my slope as 2. And so now, remember, I actually end up using slope-intercept form to make this equation. I've got to find out what the b is. I just got to pick one of these points to use. Let me just pick the second point in this case. And I'm going to fill them into slope-intercept form. 3 is the y-coordinate equals 2 for the slope. Negative 8 is the x-coordinate. And then plus b, right? I'm trying to find out what b is so I can keep making this equation. I'm going to keep going here. I can do 2 times negative 8 gives me negative 16. And then that still gives me 3 over here. Plus 16 to both sides. And I'm going to get b equals 19 is what I get in the end. Positive 19. So good. So my final, well, I shouldn't say my final equation. My final equation for slope-intercept form would look like this. Y equals 2x plus 19, which would be great, right? If that was the final answer, I could just stop right there. But if I'm making standard form, I've got to get x on the other side. So it just takes one more step. I got to subtract 2x from both sides. My final answer, negative 2x plus y equals 19. If there was a fraction, maybe I'd have to multiply everything by 2 or 3 or something like that. But since there's not, there's my final answer for standard form. Okay, I'm going to do one more problem on this page. Again, it's going to be one of these bottom ones. Again, kind of like one from each section so far. Remember, these problems say write equations that are in standard form that are equivalent to the given equation. we had a nice little trick for these, and kind of a, again, small concept, but really it seems like but a big concept in terms of understanding that equivalent equations are equations that have all the same solutions, and really on the graph they'll have the same graph, but all it is they just have different numbers involved. In standard form and in point slope form, we can see this a lot. Remember, our trick was just taking everything and multiplying it by, whatever your favorite number is. Let's say it's 8. It's just like distributing in that case. So I just got to take everything times 8. I could also divide everything by 8. I could times everything by a negative 8 if I wanted to. In this case, though, I'll just multiply by 8. So I'd get negative 8x plus 56y equals 16. And if I actually took that graph or went to Desmos or just was graphing by hand and I graphed these two equations would actually have the exact same line because they are equivalent, because I've just taken the first equation and multiplied everything by 8. And I can multiply by 10 or 20 or whatever it is, but that would give me an equivalent equation. Or even dividing, like I said. Anything will work to make those equivalent. So, okay, I said I'd do at least one of the graphing ones, so let's start with one of these ones in the back. It looks like I've got number 13 here. These problems say write an equation, and it says going back to our fun friend there, slope-intercept form, right? So maybe just as a helpful reminder to yourself, whenever you see what form you're supposed to use, especially if it tells you, maybe write it at the top or write it on that problem so you know, okay, that's what I'm trying to do, slope-intercept form. I'm trying to find the slope. I'm trying to find the y-intercept from this graph. And I think you can do both those things, right? They give you some points. Let's start with the slope. So I can see right now that, it looks like they go down -1 because we went down. And if you count carefully, it looks like you go right 3. So rise over 1. My slope is -1 over 3. Okay. The y-intercept looks to be right on the graph in this case. Here it is. I'll just make it green and highlight it a little bit, but there it is. And it looks to be +5, or the point 0.05, right? 0.5. So there we go. I've got the two things I need. I've got the slope. I've got the y-intercept. I can make my equation. Y equals -1/3 x, and that'd be +5 for my final answer. I'll do one more graphing one, again, just to help out a little bit. And actually, I know that this says slope-intercept form, so I'll stay with that at the beginning, but maybe even I'll just change it to standard form just so you can see one of those, even though I know that's not in the directions here. But here's the last one that we have to graph, it says, or make an equation from the graph. So same thing as before. I'm going to start off, though, with slope-intercept form. So I got to find the slope. I got to find the y-intercept. Okay, starting with the slope, looks like I'm going to go down and over so much, right? And if I count carefully, 1, 2, 3, 4, looks like I go down 4, and then I go to the right, 1, 2, 3, 4, 5, 6. So I go right 6. So this slope would be -4 over 6, but I'm going to reduce that to -2 over 3, and that's going to be kind of small, looks like when I write it, but you can see it there, -2 over 3. And yep, makes sense because my slope is going down as I go from left to right, so it should be a negative slope, so all that fits. My y-intercept again, zooming in on it here a little bit, here it is, it looks like it's at -4. So it's like the point 0, -4, just when I put in my equation, it'll be -4. So my equation in slope-intercept form would be y equals -2 over 3x minus 4. Now, like I said, that is what this problem wants you to do. It wants you to do slope-intercept form. So that's the correct answer. But just for fun, I am actually going to change it to standard form just to show you how one of those works again, especially with a fraction in it. So if you have to change something in standard form, or again, once you have a fraction, we got to change it around a little bit, just a reminder. Well, standard form has x and y on the same side, right? So don't worry much that this is a fraction. We still do the same thing we usually do. I'd add 2/3 x to both sides, so I'd end up getting, and I guess here's where my space is, so I'll just keep working down here. 2/3 x plus y equals -4 is what this looks like so far. And like I mentioned, this is actually not bad for standard form, but Study Island, MCA's, other teachers, they may not like, too, that you have a fraction in standard form. And even again, I'm kind of lenient, but I think you should learn how to, and you know how to now change these so that you don't have a fraction involved. Take a look at that denominator. The denominator is 3, so there's your big hint that all I got to do is just times everything by 3, and when I'm done, I won't have a fraction anymore. Okay. I'm going to, again, distribute this 3 to everything. I'm going to start with everything else first besides the fraction, just to get those out of the way. So going all the way to the back here, this would be negative 12 for the constant. This would be 3y. And then for the fraction, I'm going to use this. Remember what really happens here, why this works, is this is really like 3 over 1. And as you remember from last year, that I can cross reduce and make these 3's really just 1's. And 2 times 1 on the top will just end up being 2, so it'll be 2x over 1, which will just be 2. And now I've cleared out my fractions. That's how it'll work. So just a reminder, again, that wasn't the problem, but just showing you how the standard form stuff works again, just to help review that too. Okay, and I'll do one of these table ones as well, but realize these table ones are just like we've done for the algebra method. Don't be fooled by the fact that they wrote them horizontally. It's the same thing. In fact, it's just giving you more information than you need from the things we've done. If it helps, hey, take number 16 and just write x and y over here like we usually do, and write those same points, 0, 4, 1, 7. It's really the same exact thing. And you can even write more points if you want, 2, 10. But realize that once you have 2 points down, you already know what to do. You just find the differences. Oh, this is going up 3. Is this side's going up by 1? Remember, what that finds is that finds our slope. So I just found out, let me zoom in just a little bit here, that m equals 3. Because our slope was 3 over 1, so our slope is 3. And in this case, you could graph these out on graph paper, but take a look, everyone. Your y-intercept is right here in this particular case. Other ones you may have to graph or figure it out or do some thinking, but or make your equation and plug things in. But hey, this one, it says 0, 4, so your b is 4. So you've already got your y-intercept right there. So this one I can make the equation. Y equals 3x plus 4, okay? Now again, for other ones, maybe you want to graph these points, or maybe you want to do something where you can work backwards and you can figure out what the y-intercept is by getting when x is 0. If you keep going, take a look at the pattern here for this next one. I just want to use a different color, but look at all your x coordinates, right? 2, 3, 4, 5. Well then, imagine if you could just kind of, whatever the pattern you find to be, if you just kind of keep it going this direction, so you get x is 1 and x is 0, well then you'd find your y-intercept that way. So, a couple different ways you can do those table ones, but realize that it's a lot like we've done with tables already. Find your pattern, and that can start getting you to finding your y-intercept.